Soller's Home constructed a 650 square foot office for a hydrogen fueling station in Woodside, California. The building you are about to watch take shape is a single piece of concrete that was cast in one day at the site. Building a Soller shell starts on a computer. The forms for the shell are designed using state-of-the-art 3D modeling software. Exact coordinates for all key components are identified as part of the system design, which is then simulated. We start the building process with the points that have been set by the surveyor and establish our building's coordinate system with the same references we used in our simulation. The mounts are critical because they enable the inner form to float above the floor so that the concrete can flow under the formwork to create the slab. We survey in all mounts to within an 1/8 inch in both directions so that we know the posts are located as simulated. After the mounts are installed, we construct the lowest section of scaffolding. The scaffolding is shot in with the survey station as well. The frames are referenced to the scaffolding and the concrete wall is referenced to the frames, so if the scaffolding is correct, the forms are correct by construction. This is an important simplification because it changes the installation of the forms from a complex fabrication process to a more simple assembly process. The posts and frames are the heart of the multi-flex forming system. The posts are structural steel tubes that have stubs welded to them that enable the frames to mount quickly while maintaining the strength of the assembly. The frames are steel tubing that is sized to slip onto the post stubs and get pinned or bolted in place. The key to the system's flexibility is that the posts and frames use drive screws to adjust to varying grades and distances. All of the pieces of the multi-flex forming system are reusable from project to project, and system components can be swapped out to meet any design requirement. Forming begins at the back right corner of the building and continues with the back wall to create a U-shaped jacket structure that is about 7 feet tall. With the jacket form as a reference, rough plumbing and electrical are installed. After the utilities have been inspected, the building's pad is then completed. Installation of the rebar begins with the columns that support the ceiling beam. The multi-flex forming system allows a worker to reach his hands through the jacket forms to tie rebar while another man works from the front. With the column cages in place, the rebar for the bottom mat is bent into an L shape such that it becomes the first 7 feet of wall rebar. Once the bottom mat has been tied, the top mat is installed. The second level of scaffolding is constructed and braced, and we can move forward. Electrical conduits and water supply lines run inside the concrete walls and are tied to the rebar. Electrical boxes are installed in the wood interior or placed directly in the concrete. The non-structural wood interior is installed where needed, and special block-out structures for the windows and doors are put in. Facing is secured to the frame structure and installed when the rebar and utilities for that section are in. Plywood facing was used for this project, but the multi-flex forming system supports many types of facing, including facing that can texture the concrete on the inside, outside, or both surfaces. As the jacket facing is installed, we begin to install the rebar for the upper wall structure. This building has a significant number of concrete beams that act as headers above the openings. The rebar for these beams is installed with the reinforcement for the walls. As the upper wall rebar goes in, we install the inner frame structure in parallel. The inner facing is installed in conjunction with the inner frame structure and marks the completion of the lower walls. The ceiling formwork defines a junction between the wall and the roof and is installed above the inner frame structure. It's here that we'll stop and point out an important aspect of the inner facing. During the design phase, we can choose to prefabricate the inner facing and leave it with the casting to become the non-structural wood interior. So when we remove the forms, we already have an interior wall structure with rough electrical and plumbing in place, ready to receive insulation and drywall. This shaves significant time off the project schedule. After we close up the lower walls, we move our attention to the roof form, which must carry the 56,000 pounds of concrete and steel. This is done using a framework of steel tubes that are buttressed with I-beams. These struts that comprise the roof form connect into the top of the posts that serve as the inner wall form. Struts mount using larger stubs and have drive screws that make them adjustable like the frames and posts. There are 23 support points for the roof form, and these support points also serve to buttress the wall forms. This building has a flat roof, but by using angled connectors from the post to the roof form, pitch roofs can be formed using the same struts. With the ceiling form in place, the core form has been completed and work can begin on the roof. We survey in reference lines at the top of the roof and verify that the dimensions for the buildings are being held. The rebar for the roof and the large ceiling beam is structurally tied in to the rebar for the concrete beams at the top of the walls. With the roof mat in place, all of the reinforcement for the structure has been completed. The last step in the forming process is to install the ties that couple the jacket form to the core form. An advantage of the multi-flex forming system is the relatively small number of ties that are required. Only 60 ties were needed for the entire building. The forming is now complete and we are ready to pour. A high-strength mix is used for the entire pour, but the concrete for the walls receives a chemical additive to make it highly flowable. The wet concrete is vibrated so that it flows down to the base of the wall and around the corner to become part of the floor slab, which is poured next. The floor uses the same high-strength mix, but without the chemical additive. The floor receives a smooth finish, but could have been colored or stamped to provide a decorative touch. The roof is the last section to be poured. The roof slab is 6.5 inches thick and uses normal concrete. For this project, the top of the roof received a broom finish such that the roofing material would more easily adhere to the concrete. Again, the roof slab could have been colored and/or textured to mimic traditional roofing materials such as shingles, slate, or shake. With the roof slab poured, the casting for the entire building is complete. The high-strength concrete used for the building yielded a compressive strength of 6,700 psi, which is about twice the strength of a typical mix used for a residential foundation. After the concrete was given time to cure, the forms were removed. And what was left is the casting, complete with openings for windows and doors.